Now, his goal, and it's our goal now, is simply to get the cost low. Nuclear power is going to succeed economically, and that means we have to pay attention to cost.
Just because the facts are A, if the narrative is B and everyone believes the narrative, then B is what matters. But it's our job in our industry to speak up proudly, soberly, and to engage people in this dialogue. Those 2.5 billion people that are in energy poverty, they need us.
America cannot meet this threat alone.
If there is a single country,
of course, the world cannot meet it without America,
that is willing to
we're going to need you, the next generation, to finish the
overhaul
job.
nuclear regulation,
We need scientists to design new
and
fuels.
focus on net public
We
benefit
need engineers to invent new technologies. We
over absurd levels of radiation
need
protection,
entrepreneurs to sell those
then
technologies.
we will march towards this.
We need workers to operate assembly lines that hum with high-tech,
where
zero-carbon
we have
components.
unlimited prosperity for all humans.
We need diplomats and businessmen and women and Peace Corps volunteers to help developing nations skip past the dirty phase of development and transition to sustainable sources of energy. In other words, we need you.
Okay, welcome to another episode of the Fire2Fission Podcast, where we talk about energy-dense fuels and how they can better human lives. My name's Mark Heineman, and today I'm joined by Bob Hargraves, co-founder at ThorCon International. Bob,
Pleased to meet you, Mark.
And it's great to meet you. I've known of you for a long time. I've heard of you speak on several podcasts. You're prolific on LinkedIn in posting about the nuclear industry and advocating for it. So I'm really excited for this discussion. I think it's going to be excellent. Bob, before we get started, why don't you just give kind of you've had a long background, but why don't you give kind of a brief 30 to 60 second self-intro, tell the audience who you are and give them color for this discussion.
Sure. I started my education at Dartmouth College. I started to be an engineer, but I liked math and physics better. I couldn't figure out which I liked better, so I majored in both. Then I went to grad school with Brown in physics. I studied high energy particle physics. So I have a little bit of nuclear background. After that, I got recruited back to Dartmouth and worked on time sharing and new computing. I introduced computer science to Dartmouth College and so on. Then life went on, and I founded a software company. We were one of the first outfits to license software at the amazing price way back then of $7,500 a month for a time sharing system software. So we made a bunch of money for the college who owned the company. And then I ended up being an insurance company executive for a little while, and then became a consultant with Arthur C. Little. And of course, in consulting and in IT, the people who buy a lot of services turn out to be the energy industry. So we did a lot of work around the world with oil and gas companies. Then after that, I got involved in a medical device company, Boston Scientific, which was exciting and fun, and eventually retired and got the bug of my physics background alive again. And I said to myself, what's going on with energy? Why are we paying all this money to the folks in the South, in the Mideast, and got involved in nuclear power? So this is a 2-decade retirement project I've been working on.
Excellent. Selling IT services to oil and gas industry. I imagine, was that in the 80s, 90s? What time frame was that?
That's right. We went to places like Venezuela, Brazil, of course, Saudi Arabia and Kuwait.
Yeah, that's great. My dad has told me stories about that era, and it was very analog. So what were some of the IT technologies that you guys were peddling then?
No, I do remember being asked to be a consultant on a project. Someone had to convert teletypewriters to Arabic, and I foolishly said, no, teach all the Arabs to be using English letters. That was a mistaken piece of advice.
Yeah, that's funny. My dad has stories about my mom. They worked together and they ran a business together, but she would be up till the wee hours of the morning typing up proposals on a typewriter, that they'd take into a bank meeting or a customer meeting the next day. And yeah, it was different world. So, well, Bob, when you got interested into nuclear, tell me about that discovery process.
The discovery process was the idea that we shouldn't spend so much money in the Mideast, frankly. And I started looking around, and I got very entranced with the pebble bed reactor and Andy Kadak's work at MIT. Andy was the guy who had run one of the very first power plants in New England, Connecticut Yankee, and he was the teacher at MIT who was pushing that kind of a project. So I put together a blog called Pebble Bed Reactor. My theory is if you don't know something, teach it or post it or whatever. And so that was a series that lasted for a couple of years. And I was big on it because of the intrinsic safety of the fact that these little pebbles contain little grains of fissile material that are themselves contained in little spheres that contain all the fission products. So that you don't have the worry that you have a whole raft of radioactive materials in any kind of an accident. So I liked that idea. It is a little expensive to try to compete with oil. So we got sort of interested in other technologies. And just from looking around, I noticed molten salt reactors. And the guy who was a big proponent of that was Kirk Sorensen, who now was the guy who runs Flibe Energy. Kirk's background was NASA, and he got involved in how one might put a power plant on the moon. And then he got involved in finding out about the work that had done at Oak Ridge. And he managed to get a grant to get all those documents for the project scanned and put on the internet for everyone to look at. So I got very interested in that. Wrote a little book on it called Thorium, Energy Cheaper Than Coal, and began to meet people. One of the people I met was Jack Devaney. And Jack had an astounding idea to me at the time, and that was to use ships to become power plants. And Jack had put his money where his mouth was in the sense that he had designed and built and raised money for the world's largest double-hull supertankers that transited oil back and forth from the Mideast to the U.S. and other places. And in doing that, he had used his education and his contacts at MIT, where he taught or worked, to develop a system of engineering design that was very complete and very consistent. He was an expert in using all the tools. And so he managed to sketch out how one would do that with molten salt reactors and ThorCon. Now, his goal, and it's our goal now, is simply to get the cost low. Nuclear power is going to succeed economically, and that means we have to pay attention to cost. And when I read the news about nuclear power day after month, I see little attention to cost other than saying they're blowing out of sight. The emphasis on new nuclear power seems to be smaller, modular, factory produced. That's all good, but safer? Come on, how could it possibly be safer? No one's injured in the U.S. by nuclear plants. So we need an emphasis on cost. We want the cost per kilowatt hour to come down if we expect nuclear power to succeed in providing clean energy to the world. So that's kind of the objective of the company that Jack initiated, ThorCon Power. Energy cheaper than coal, factory produced, scale, so that we can fulfill the goal, not just of building a molten salt power plant, but a whole system that's in place that has the capability to provide power to the world at scale.
Yeah, that's wonderful. So I love that Jack's background is in the oil and gas industry also, right? I mean, I empathize strongly with them, and that was probably helpful for you to come to them and be like, oh, I've worked in energy and oil and gas. And it's just fun when people get it and have that background and then come to nuclear. How did you get connected with him originally, and what was your guys' relationship that you decided to join him?
It was a mistake. Somehow or other, it was a piece of documentation he'd written that somehow escaped through one of his friends, and I found it. And I said, my God, look, this guy has the answers. He knows that power plants are built the same as ships, with pipes and pumps and valves and so on. And it's the same technology. So I broadcast that to two or three guys. Jack found out about it. He said, oh, my God, secret's out. So his deal was he recruited all of us to basically work with him. And that's what's happened instead.
I see. I like that. So before we talk a little bit more about some advocacy stuff, let's focus on ThorCon for a little bit. I mean, you mentioned it's a company that's focused on molten salt reactors, building power plants with ships. Are these going to be mobile? How big are they? What's the power rating target? Give us some color.
Sure. First, the plant is built on a ship that's perhaps 165 meters long. The width is approximately 65 meters because that's the size of the docks that the shipbuilding companies use to build ships efficiently. Now, we also want this plant to be cheap, so we want the economies of scale that can be achieved. So that's kind of the background for setting the size of the power plant, which is basically two 557 megawatt thermal reactors on board the vessel and one steam turbine generator that can output 500 megawatts electric. So that's kind of the sizing. And with that size, we are able to get the cost for the power plant, the capital cost, down to something like $1.2 per watt of generating capacity. And the goal we still have in our design, it still is achievable, even with the inflation, is about 3 cents per kilowatt hour for the electricity that's generated, all costs taken into account, coming from the ship. Now, on top of that, you have to add transmission and regulation and marketing and all the other sorts of things. So perhaps that cost gets doubled by the time it gets to the consumer.
Yeah, that's really good. Well, $1.20 for overnight capital cost is excellent.
Yeah, right.
I just did this calculation and looked back at it. Peach Bottom, which was one of the least expensive nuclear power plants built in the U.S., was $1.20 in 2008 dollars, or $1.80 in 2023 dollars. So you right in range with some of the cheapest power that the U.S. has ever built.
And a lot of the reason for that is the shipyards. I mean, the shipyards have been brutally competitive in South Korea, Taiwan, Japan, and so on. And if you've ever seen some of the videos of how they build those ships, they're very impressive. They have large machines that roll the steel and form it and weld it and on and on. And so the design of the power plant has been set to make use of that technology so that they can be built by inexpensive shipyard technology.
Absolutely. Now, you guys have this design on your website. You have some excellent documentation for vendors and suppliers. And I mean, it's obvious that you put a lot of thought and effort into this.
Yeah, the website has a sketch of an early design, perhaps a couple of years old.
It's not the latest and greatest, eh?
Yeah, what happens is, of course, now we need to have more engineering, more work, and so on. We need more investment. And so the investors want to know that there's a proprietary basis that will mean that they can earn their money back and more besides. So there's a lot of material that's proprietary to us. As the design is advanced, we can't really post it. Some of the new ideas we put there. But again, the process in every decision is, what's the effect on cost? What's the effect on production, producibility, I should say, and so on. And there's some clever ideas in the new design. One of the things that's there is we have decided to split the nuclear module into a separate hull. So that we'll probably be releasing that. Some of that's probably on our news sites from time to time, but we want to be able to take just that part of the power plant to a maintenance facility and leave the very expensive steam turbine generator in place. So there are changes like that have happened. So the website is a good place to begin your education in how one might put this sort of thing together, but the real details are not published widely.
Got to get in touch with you guys to get behind that curtain. So, so Bob, give us some perspective on where you are in this process. Do one of these plants exist yet? Have you guys built a prototype? Are you looking for customers? Help me understand how you're going to make this come to fruition.
Right. First of all, we have a lot of clever engineers, and they're not in the nuclear industry. So we've linked up with a company that is in the nuclear industry. Empresarios Agrupados is a Spanish company that has done the engineering documentation and so on for many nuclear power plants in Europe. So they have that kind of experience in putting together the documentation the regulators want. And they're also a sounding board for us, who are people who are good engineers and have education background in consulting in nuclear power plants, but they are a check. So we make a presentation to EA, we call them, Empresarios Agrupados, and they say, oh, well, what about? Because they've been in the same position with regulators in the past. So that's working well. We also have a plant that's going to be towed across the sea. So we have a relationship with Bureau Veritas, which is an outfit that helps ship manufacturers get the various accreditations that are needed to bring ships into port and so on. So that's helping us, and we're trying to split the plant, as you see, to try to keep the regulator from having to look at every detail and things that aren't very important to nuclear safety. So, for example, in our design, the whole steam power plant is not critical to the safety of the nuclear module. So we're going to try to get Bureau Veritas to be the people who attest to the safety and seaworthiness and so on of that part of the plant, and limit the regulators' concerns to nuclear power and the chance of harm from radiation. So,
got it. Being a ship, you can deploy these things anywhere. I think you've targeted Indonesia. I don't want to put words in your mouth, but are you guys still focused on that area of the world, and what's the status there?
Well, yes, we are. I mean, the original design was to be built on land using the same construction techniques that we would use to import big sections of the plant from the shipyard. But that evolved finally to actually having the whole plant built by the shipyard. So the idea we had was to build a plant as on a ship, but only for transportation to the site. We finally decided that there were more things to constrain us if we wanted to have a floating power plant. For example, the regulator doesn't have any rules for that. So we take the whole power plant to the site and we ballast it down to the seabed, so it becomes a land-based plant with its feet in the water, so to speak. And therefore, all the regulatory rules that apply to land-based plants apply to us, and so we don't have that new ground to plow over. Also, we have little details like how do you make the electrical connections to power plant that's bobbing up and down and so on. We're trying to reduce the number of new technologies we want in the power plant, just to make the chance less. So that's what's happened. We need about 5 to 10 meters of sea depth in order to bring the plant into place. We prepare the ground underneath the sea with sand and so on, so that we have the proper relationship between the plant and the ground in the case of earthquakes. So that's part of our seismic isolation. It's, as I said before, that's not going to stay there forever. We've decided that we want to be able to tow the nuclear module away to a maintenance facility. So that's going to happen every 8 years or so, to do that sort of thing. We could relocate the plant by deballasting all the water that's in the double hull and float it off somewhere, but that's not the idea. The idea of floating power plants was simply, in our case, to transport it from the manufacturer to the seaside site. Now, seaside, of course, has another big advantage, and that is cooling water. We got a lot of it out there, and it helps us keep the cost down.
Yeah. What's the timeline to deployment? Do you guys have that mapped out? Do you have a prototype that you've put together, or?
Well, like in all engineering projects, there's the business side, and those people have a schedule. It's written, and here are the goals and so on, and here are the milestones. And there's the engineering side, who have to try to meet those and so on. So there's always that kind of conflict. But now we're looking at being in testing mode on Galasa Island, Indonesia, in 2028. And let me tell you a little bit of how we got there. We took that initial design to the NRC and to the Department of Energy and did the presentations. And Jack had the idea originally that we could do that at Hanford, which is a site in Washington State where the plutonium reactors were built to provide that fissile material for bombs for World War II and thereafter. And it's been always a controversial site because it's military, really, and because people complain about the leftover materials that are radioactive from the old plutonium power plants. Now, it turned out that, among other things, was a whole set of perfectly workable, never used cooling towers right there. And so we had proposed trying to build a plant there. But we were asking to build under the same licensing rules that all the other plants in the United States had been built. But the NRC has changed all the rules since then. And they said, no, you have to use the same rules we use for new power plants. And so we did our duty in telling the government what we're going to do, but we couldn't do it there because at the very time we did it, the general, what is it called? The GAO, Government Accountability Office, did a study of what it would cost to build a new technology power plant. And they came out with a report about the time we were there that said it was $1 to $2 billion before the NRC would rule. Okay. So you can't imagine going to an investor and saying, please, can I have $1 billion? And by the way, it all depends on the whim of the NRC.
Let's dive into that a little bit. I'm really curious about this. So Government Accountability Office, this is a government agency that analyzes other government agencies and makes sure that they're operating efficiently and under their purview and their rules. Am I correct in understanding that?
Sure.
Yeah, and so they studied the NRC and they said it's going to cost $1 billion to license a new nuclear power plant in the U.S.
To get right, exactly. So then we get to build.
When was that, Bob?
Oh, that's all at least 10 years ago.
Yeah, and so I think NuScale then proved that, right?
Well, you're right. Yeah. Yeah.
Because how much? I mean, you look at their any of their reports, and they've spent $1 billion getting a design certification.
And yet, NuScale is the same technology. It's pressurized water in a reactor
new tech, right?
with with a fuel rod length that's half as much. It's improved the design to be more passively safe, for sure. So it's better in a sense. But why is it so?
So is that report public? Can we go back and look at the Government Accountability Office report?
Yeah. Probably in one of the presentations I've done on the website. Yeah. So it's certainly there.
So I want to stay on this topic just real quick, Bob. But do you see that changing in the next 5-10 years? 2 years, 5 years?
The only way that will change is with a kind of a revolutionary approach to regulations in the U.S. I mean, incremental changes to the NRC are not going to be effective.
There needs to be enough pressure on Congress to make big changes to the NRC so that it doesn't cost $1 billion to license these systems.
Right.
Which is radically unnecessary. Like you said, there's never been an accident that's hurt somebody in the U.S. Anyway, I can get off the soapbox for a long time.
The other option is to escape the NRC. Now, the Navy escapes the NRC. Okay?
Yeah.
And one of the articles I wrote a little while ago was suggesting that the chemical industry ought to escape the NRC. The oil and gas and chemical industries run very hazardous plants all the time, reasonably safely. And Dow, for example, has just said, we're going to put a nuclear power plant in ours to generate heat and so on cheaper. And my point is, well, these guys know how to handle hazardous things. Let them do it.
Yeah.
Why have the NRC involved at all? I divert. I digress.
Yeah, make sure that the material is not stolen. But okay. So or escape the NRC by going to Indonesia, right?
That's another point, of course. And that's our objective. So when we got turned down in the U.S., we started looking for other countries. And we had a 6-month campaign about trying to find a country that wants us. We went to lots of countries, Bulgaria, Jordan, UK, you name it, and trying to find the right match of openness. And Dave Devaney finally found Indonesia. And Indonesia is the 4th largest country in the world by population, and perhaps has, I don't know the exact number, but a tiny fraction of the GDP per capita of the U.S. It's probably, an eighth of it or something of that nature. They want more energy. They want more power, like every nation. They have resources. They'd like to excavate them. So, for example, they would like, rather than sending coal away and sending iron ore away and so on, to use those natural resources to make products, steel strip or aluminum or whatever. And they need energy in order to do that. And they know that. They're all smart people, of course.
Yeah.
So they've been sort of open-minded with us all along now, and we've been working hard with them for half a decade. Most recently, about a year ago, the governor of one of the provinces, sometimes called Babel, B-A-B-E-L, wanted the project in his province. And so he suggested we use an island that we visited called Gilasa Island. And it's uninhabited. And our idea is that if we do this on an uninhabited island to begin with, we will be certain that there won't be any hazardous results from mistakes. And also, we're kind of out of the mainstream of all the protesters who are going to be around and so on. So
make sure all the stakeholders are involved. We got all the birds on board? Cool. Sounds great.
Now, we've had, we've had PLN, the power company, go to the island, and they've done surveys of the subsoils underneath where we're going to put the hull. They've figured out how to bring the power in an undersea cable, designed that, and so on. So they're involved. The regulator went not to the island because nobody there, but to one of the cities nearby in the province, and had an open discussion with the people there about how ThorCon would affect them, and so on. So that's progressing. Like any government, there are a lot of agencies involved, and the regulator is just one of them. And we have relationships going with all of them. So we have an office there with a manager and a couple of dozen people who are interested in handling all the relationships with the government and the people and so on, and just public relations. And it's working pretty well so far.
That's great.
So that's how we came to Indonesia.
How many countries did you guys look at around the world?
Oh, I would say a dozen.
Yeah.
Yeah.
At least, right? I mean, did you visit all of them? What was your vetting process like, if you don't mind sharing?
Well, what's the vetting? I mean, regulatory hurdles is one vetting. Another is the openness, the stability, the democracy of the government. Another is, of course, the demand.
How likely is it if there's going to be a revolution? Are they going to nationalize your technology? Or
all that sort of thing. Exactly. Right. So,
Okay.
So Indonesia is it. But, we have to raise more money in order to meet that schedule of having that plant under test on Galasa Island in 2028.
Got it. Okay, so back to fundraising piece now. So you're back to fundraising now, right? Yeah.
Right. Well, we had a handful of investors to start off with, and these investors are people who say, well, we ought to help these guys out. And one of the investors is one that invested in Jack's project in the first place. So, but these are small investments made by people who are concerned about the plight of the world and CO2 emissions and all that sort of thing. And the most recent one is the one who's our principal investor, Chris Anderson. And he's been carrying the company through the last over a year now. Chris is the guy who founded the TED Talks and feels that our idea is the same as Musk's idea in the sense that we're building a factory to produce the product. So that's kind of it. I was impressed with Musk in the sense that he merges manufacturing with design. So he moves his engineering desks to be alongside the production line, so the engineers see what's going on all the time. And when you're building a new thing, the NRC and everyone else in ISO 9000 would say, well, we write down all the design requirements, and then you follow and you document every step of the way until you have the finished product that meets the design you did 3 or 4 years ago. Well, when you're developing a new product, it doesn't work so easily that way, because as the design evolves, there's a materials problem or a sourcing problem or you name it, it goes on and on. So there is a lot of interaction that happens as that design progresses. But now we have the design in a state where we would call it a preliminary design. We know the pipe sizes, we know the materials, all that sort of thing. But the hangers that the pipes are hanging on, those aren't designed yet. Okay, so we're going to involve outfits like EA to finish off that kind of design. And as you approach the shipyard is going to say, well, we don't want to. There's a question: who wants to do the final design that's going to really affect the manufacturing? And that has to be negotiated still. Dave DeMatting was just over in South Korea talking to one of the, Hanwha Ocean, which is the new name for DSME.
Yeah.
So
now
go ahead.
Yeah, sorry, didn't mean to cut you off, but I mean, searching for investment sometimes it can be easier to raise smaller amounts of money than larger amounts of money. And I'll preface this question with, I emailed Jack actually and said, hey, we're really interested in these microreactors and this kind of idea. What do you think about them? And background for the guest, Jack has run a blog called the Gordian Knot, and the Gordian Knot is kind of it's this longstanding idea of how do we solve climate change and not impact the planet and still provide energy for everyone. Or that's kind of the premise. I don't want to put words in your mouth or in his mouth, but He emailed me back. I was like, hey, we like microreactors. And he emailed me back and he goes, we're not going to solve the Gordian knot with toys. We want big reactors.
Now, right, that's true. There's a market for those small reactors, small remote villages in the north, something of that nature.
Yeah.
But again, we tried to get the cost per kilowatt hour down as low as possible. And that's kind of means scaling up. So that's the point of Jack's remark. Now, let me talk about SMR shift for a minute. I just came to this realization a while ago that these small modular reactors that are in vogue are really just water-based reactors. They transfer heat from fuel rods to eventually a steam turbine with water. And to keep that water from boiling, they pressurize it. We had a boiling water reactor from heat. They doubled the pressure in order to make a pressurized water reactors for Westinghouse, but there's a limit to how much you can pressurize it and have an efficient system, and that limits the heat transfer. So a lot of these new reactors are just the same technology. The NuScale, the Holtec, the Westinghouse, the Advocacy claims, and they're advertising the new design as it's the same as the AP1000, same pumps, maybe fewer of them, and so. And that's a good idea. I mean, they've been through the regulatory rigor and they checked them all out, on and on. So, but how is that going to really lower the cost?
Yeah.
So we got involved in new technology. I told you I got interested in the pebble bed reactor, the high temperature gas reactor. And now I am in the molten salt reactor because we believe that technology can be less expensive because it doesn't have all these fuel rods problems. I mean, the technology of a fuel rod pellet is pretty intense. I mean, what is it, 1500 centigrade in the middle of the pellet? And the boiling water is what, 300-400 degrees centigrade? You got to have that transition in a centimeter or so. That's something.
The materials are unbelievable, right?
Yeah. So anyway, so
with this 2028 time frame, I guess what I was getting at with the anecdote about Jack saying we need big reactors, but that could increase the capital cost of the first one. Have you guys given any thought to building a smaller prototype first, or are you kind of taking the Rickover approach where he said, nope, we're building a submarine, it's going to be full size, and we're going to run it underwater the first time that we turn it on?
Well, Rickover was advanced system, and when he did that, there was no example of such an engine powered by nuclear heat. In our case, there is an example, two actually, down at Oak Ridge, the aircraft reactor experiment and the molten salt reactor experiment. Both of those were operating. And it's amazing how much good documentation exists from that last experiment. Forever going back and saying, well, what did they do in this case when we come across a problem? So in a sense, that small reactor has already been developed. Now, just from being in the meetings and so on, I can't see if we had made the reactor half the size of what we're making now, I can't see any change in cost. I mean, the cost of the people is all the same. And the other problem I've noticed in my introduction to engineering is that none of this stuff scales. Fluid dynamics is different in a 1-inch pipe than a 1/2-inch pipe.
That's true. Yeah, it is true. That is a good example. I mean, it goes both ways, but the Fort St. Vrain plant in Colorado was designed by Combustion Engineering, and they had built a prototype that was about, I forget, it was like half the size or a quarter of the size. And they said, this works great, right? And then they just scaled it up. And then when they did scale it up, they had more leaks. The helium didn't circulate the same way. You're exactly right. There was nuance to the size of the design that building it the right size the first time would have been helpful.
Right. And remember, our objective is not to build one plant, but to build the factory and have a design that provide safe, clean power to the world. And if we succeed, we can have an outfit, a shipyard build perhaps 10 to 20 gigawatts of power plants a year.
Yeah.
Right now, we're competing with, of course, the oil industry, because the oil industry wants to build tankers and LNG tankers now, of course. And so the shipyards have to balance the demand from a startup like ThorCon with proven but variable demand for LNG tankers, oil tankers, and so on. So they would like to have a different kind of customer themselves. So that's our in with them.
Bob, what's the number? I mean, it sounds like you guys are looking for more investment now. I would ask, what's the number one thing that you guys need? Is that an investment partner, a team, or more customers? Or sounds like you've got a lot of the engineering and design thought out.
Well, thought out and being tested in a lot of cases. We have a lot of component tests going on. A lot of this stuff is outsourced to various labs around the world. So it isn't just the design that we have lots of parts in manufacturing. They're being tested all the time.
But what do you guys need most right now?
Honestly, it's frankly a good, firm, reliable investor. I mean, Chris Anderson, who did the TED Talks, is a great partner, but he doesn't want to spend his whole fortune. He's only done TED Talks. He doesn't own a bunch of railroads. So
diversify.
So he's in the process of trying to convince others, as we all are. And I do some of that. That's one of the reasons for all the LinkedIn posts and so on, just to attract attention to what we are doing.
Yeah. Well, I think you're making a lot of excellent points and advocacy work for the industry. And, I view it as a full court press, meaning we collectively need to encourage this technology and normalize the adoption of it and the utilization of it. And I think you guys are doing a wonderful job on LinkedIn and in other outlets to do that. So let's pivot to that. Let's talk a little bit about the Gordian knot. Your post on LinkedIn, you repost a lot of what Jack writes. He's got a Substack.
Right. The problem is, although we have some good ideas, the question is, who knows about them? And all of us guys in the sort of pro-nuclear community speak to each other. I've gotten 4 or 5 articles into the Wall Street Journal, but the New York Times, for example, never even replies when I send them a draft of an article. So the media controls the message that the public understands. And they understand, for example, anytime I talk about what I do, I'm always asked, well, what about the waste? Right? And, so the public has been conditioned to do that. So how do we get that message out to a wider audience is the question. Yeah. Now, honestly, I think if we can get that power plant up and running in Indonesia and publish the prices, that will disturb a lot of people in the world, and they'll say, I wonder why we're not doing that. Okay, so that's the primary thing. Jack has operated the company to Dave Devaney, his brother, and Lars Jorgensen, the guy who runs all the engineering here in the U.S. So he's now on a campaign that you have seen, the Substack posts, to basically try to present the silliness of our regulatory blockade that prevents nuclear power. But again, who's going to publish that? I'm also involved with a group called Scientists for Accurate Radiation Information, which is a group mostly of oncologists and docs and radiologists and health physicists and so on, who deal with radiation as a career in hospitals and so on. And they too are trying to get the science applied to the regulations. But it's sort of frustrating because things like the Well, LNT is a model for the harm to health from radiation that's absorbed, called linear no threshold. And what it means simply is that if you double the dose, you double the harm. Or if you have the dose, you halve it. But that's been interpreted as saying, well, there's no safe dose. There's always on the risk you're going to get a deadly cancer. That is a tenet of EPA. By that I mean a policy. And they judge any scientific paper in the context of the policies they have set. And the policy for cancer is anything that can cause cancer is regulated as LNT. Now, you mentioned Jack's idea about what's called a sigmoidal curve. That is, there's a kind of an S curve in the sense that dose response. In fact, there's a journal called Dose Response in the medical industry that says how much of a dose is the proper dose to cure this particular problem. And throughout biology, we in medicine have always said that the dose-response relationship is an S curve. And that's Jack's idea, is to say, well, why isn't that true for radiation? Well, it turns out it is true for radiation. And that is a problem because the EPA's policy is that it isn't. So,
yeah.
So we're trying to get that. Now, a number of people have tried to get some of the research papers that founded these ideas withdrawn. We've had frustrations in doing that. But you've probably noticed in the news, there's a lot of now new evidence about faking it in publications. So the world may be more open to realizing that some of these scientists, like Mueller 80 years ago, actually ignored the data that was controversial to his ideas so that he could get the Nobel Prize. And so there's a lot of that, work that's going on. I had a friend of mine say, what is the one thing a Nobel Prize winner wants most of all? And the answer was, another one. Anyway, so
that's good.
The competition and self-promotion is important in lots of things. To get ahead, to get the science done in your lab is one thing, but to get it published in the popular press is another. You need to be able to popularize your ideas in order to have them be effective. And we haven't done that well enough in the nuclear industry. The whole industry is always on a back foot saying, well, it's safer. No, radiation won't hurt you. No, it won't, on and on. We're not promoting what's going on. So let me just, for example, give you a couple of ideas about what I call new nuclear. By new nuclear, I mean the new technologies that aren't water-based, such as molten salt reactors, such as high-temperature gas-cooled graphite pebble reactors, and so on. Because they're at higher temperatures, they're more efficient. One of the benefits of ThorCon is that 50% more of that heat energy from fission becomes electricity. Okay, for the same fuel, we can generate 150% of the electricity that you could possibly generate with a pressurized water power. So that's one advantage, that we don't push hard enough. Another advantage is cooling water, the rejected heat in a turbine. With high temperature heat, we basically can cut the cooling requirements of a power plant by half, literally, per kilowatt hour of electricity that's generated. So that's a very important advantage. Now, we've always been saying, well, about a third of the emissions of CO2 in the world are from power plants. If we replace them with nuclear power, we'd get rid of a third of them. And that's good. And we've talked about, and I've written a book called Electrifying Our World, which says, what about transportation, trucks and so on? And I was big on batteries, electric vehicles and so on, but electric vehicles aren't the savior we thought they might be. They kind of ruined the landscape by requiring the tons of materials to be excavated for every battery that's built, on and on. So it's not an easy solution. But I got interested in new fuels, and I wrote these articles on nuclear gasoline and nuclear diesel and so on. The point here being that the high temperature of the new technology, the new nuclear, enables other technologies, such as the copper chlorine cycle that makes hydrogen out of water. Okay, and it can do it much more efficiently than you can with electrolysis. So there's an opportunity there to begin to use the high heat potential that we're not doing. So with high heat, in order to make gasoline or diesel fuel, we need hydrogen and we need carbon. Now, strangely enough, it's hard to find carbon that you don't dig out of the ground. Okay, if we dig it out of the ground and burn it, it adds to the CO2 in the atmosphere.
It's real cheap, though. It's so cheap.
I know. I know. So natural gas, $2 or $3 an MMBTU, right? It's pretty cheap. Yeah. But if we want to make a city fuel that is climate neutral, people have been, for some reason, focused on direct air capture and somehow or other thinking that we'll solve the whole climate problem by burying all this stuff back in the ground. And anybody who does the math, anybody who's been in high school should be able to figure that that's not feasible. But the other thing that I noticed is that the seawater density of CO2 is over 100 times that of the air. And if you're going to cool the power plant with seawater anyhow, why don't you look into seawater for things like CO2? And chemists are advancing. Ever since Ola did the methanol economy and things like that, there's been great advances in fuel chemistry. And it's conceivably possible to get that CO2 out of the water at an economical cost and build a kind of a refinery that merges carbon and hydrogen to make these various molecules for gasoline.
Yeah.
So it's possible we could have net zero fuels that we burn in the exact same engines we use today.
Yeah.
That would be another third of the CO2 emissions.
I loved your op-ed. I mean, you published it in Grid Brief, right? Emmett Penny published it, and then you posted on LinkedIn. But yeah, it was this op-ed about synthetic fuels and articulating just this idea that you summarized very succinctly. Use the heat from nuclear power, grab hydrogen from water, grab CO2 from a higher dense source, not necessarily air capture. And this is an idea that I don't think gets talked about very often. A lot of people don't know this. They talk about sequestering CO2 in the subsurface, but CO2 gets sequestered naturally in the seawater and in deep sea, right? Like I've got a friend that is very aware of this, and he's like, let's just pump it into the ocean, and then it's sequestered naturally there, and it's a great storage tank for it, and then you can go back and grab it whenever you want.
Maybe that's the point too, yeah. Right. Yeah. Right. I guess the point being that it gets pressurized, becomes a liquid, and really deep in the ocean. It just can sit there in a kind of a pool, hopefully.
Yeah.
Anyway. But that work has been initiated by Heather Willauer at the Naval Research Lab about 10 years ago. She started a group that did that. She hasn't yet been convincing the Navy enough to put frankly, the billions of dollars into it that would be needed to actually pull off the stunt of building refineries. A refinery costs like $5 billion. They're expensive.
Yeah. So, Bob, you mentioned it. It sounds like you've seen this phenomenon of an echo chamber in the nuclear industry. We just talk to ourselves. I'm curious, have you guys considered going and talking to other members of the energy community, or have you guys engaged with folks in the oil and gas industry or in the coal industry?
It's kind of frustrating, isn't it? I mean, I've invited myself to the Sierra Club, but never allowed to speak.
Hey, that's a different story. I don't want to talk about those people. I've got strong feelings about it.
All right, but I think I don't know how to get invited to broader forums to present the stories. Now, Chris Anderson would probably be jumping up and down because the TED Talks are such things, right?
Yeah.
So maybe we should do more of those kinds of things.
Sure. Well, I've got some ideas. I'll plug you in once we stop recording. So.
Okay.
Okay, so in your perspective, has public opinion been shifting over the past decades? Has the work that you've been doing been effective? Are you seeing momentum?
Well, if you look at this, the polls that are published, the people are a little more open-minded about it. And I think as they see the rising cost of electricity and the negative articles about offshore wind and how expensive that is, they're going to become more open-minded. But I don't think we're there at all. And Jack's point is that what happens in the next event? What happens the next time we have a power plant explosion or whatever it is? People are going to be upset. Oh my God, there's going to be radiation. And even now, you see articles every day about the Fukushima water releases, and they get a lot of press because it makes news. The fact that it's so far from being harmful is negated by reporters who really have no idea, and they have the concept of balance in reporting. So they ask the anti-nukes and they ask you or somebody who kind of knows what's going on, and they say, well, we presented both sides of the story, but the thing that attracts people's attention is, oh my God, what's going to happen to my kids? Right? So
Yeah.
It's a hard situation to overcome.
Well, I think we're making progress.
Yeah.
Maybe that's just the optimist in me.
Again, our objective with ThorCon is Indonesia. If we can demonstrate a plant and then 2 plants and then 4 plants generate electricity and having an impact on the economy of the country, that will mean competition with the U.S. and the EU. Okay.
Yeah.
And people will then say, well, wait a minute, what's going on here? But that's going to be a decade or 2 away.
Well, I hope we can get there faster.
Me too.
What would you say is the most impactful step that we can take to get there faster?
Better education. When I look at people, for example, in the climate science world and all the articles, so many of the ideas can be easily dismissed with a pencil and paper. One of the things we should do before we tackle climate science is educate people in basic math, basic physics, basic chemistry.
Man, the Inflation Reduction Act would have been written so differently if that were the case.
Right. Because, I talked to a politician once, and he said, well, you come in here with all those slides, they look great. I'm convinced. But then I have the other guys come in, and they have a nice presentation too. I don't know how to choose. And I'm sympathetic to that idea. And, what it comes down to is you have to make the choices yourself. Humans have to learn how to do, what's the right word I use? To make your own decisions. When it comes down to it, you really can't trust some politician to be on your side or trust that scientist. You have to have enough foundation and basic analysis.
Independent, critical thinking. To be autonomous.
Right.
Yeah.
Well, why did that guy say that? Not what did he say? Why did he say it? And does it jive with all the other stories I've heard? And why are all those people saying the same thing? We have this situation where it's so easy to do a correlation when you see data about nuclear power plants and cancer in children that people publish articles that say, see, cancer is caused by nuclear power plants. One of the latest ones we saw was in Europe. They said cancer in children was caused by power plants, and it turns out they had 12 cases of cancer and 17 power plants in the data set. And the power plants were all located in industrial zones that had chemical industries and every other darn thing. It's easy to say correlation and link, and suddenly the reporters are on it to make a story because they got to get paid too.
Yeah.
So you need critical thinking, and it isn't just if you're a chemist or a physicist. If you're an economist or an accountant, anybody who says, add up the numbers and look, look in the tank and see if there's any corn oil there.
Yeah.
Yeah. So
Well,
hopefully,
Bob, why don't you? This has been great. I've really appreciated this conversation. Why don't you leave us with the most positive vision of the future? What's the world going to look like once you guys get one of your reactors up and running, and then you get two of them up and running, and then you get 10 of them up and running?
well, the most positive view of the world is we stop sort of ruining it by mining so much stuff. And the other thing is that people are concerned about is population. Remember, we're talking to a market in Southeast Asia, which is enormously bigger than the EU and the US and so on. And one of the concerns is that that's all got to grow, and how are we going to grow it? We're going to generate CO2 and so on. Well, actually, the more prosperous people are, the more satisfied they are with 2 or fewer children. In fact, if you read Our World in Data, we have long ago passed child, that is, world childbirth have peaked. They're going down. Our world population will never exceed 10 billion. We already, even in India, have fewer than 2 births per woman, even in India now, as India becomes more prosperous. So we might find ourselves in a situation where we have cheap energy from nuclear power for electricity, from synthetic fuels and so on, in a population which is not exploding, as a lot of people fear, but is retreating to a level of comfort and environmental equivalency that is satisfactory for a few centuries more. So.
Yeah. That's wonderful. I love that.
Okay.
I love that vision. So, Bob, this has been wonderful. Thanks so much for the time.
Thank you, Mark.